morning students. Today we discuss about work energy theorem for variable force. So here, in the case of work energy theorem for variable force, consider a body. If you consider a body of mass m, it is laying on a horizontal floor. Now, a variable force F bar acting on the body, then this body is displaced some distance. So here, this is the displacement covered by the body in its own direction. So here, F bar and ds bar along the same direction. So these are the two parallel vectors. We know that the angle between any two parallel vectors is equal to 0. So here theta equal to 0 degrees. So in this case of this situation, a small work done is given by dw equal to f bar dot ds bar. So here f ds into here theta equal to f ds cos theta. Here theta equal to 0 degrees. So therefore cos 0 equal to 1. So therefore f ds. So here s is the displacement. Here s is the displacement. Here f is the variable force. It is not a constant force. Okay. Now we know that according to Newton's second law, according to Newton's second law of motion, F equal to ma. Here a is the acceleration. Acceleration means the rate of change of velocity is known as acceleration. So therefore f m into dv by dt. Here acceleration is dv by dt. Now this value is substituted in equation 1. So this is the equation number 1. So this value is substituted in equation 1. Now we get from equation 1 dw, small work done dw is equal to f into ds. Here f means m into dv by dt into ds. So now dw equal to m into here ds by dt. We can written as ds by dt into dv. We know that ds by dt is called as velocity. The rate of change of displacement is known as velocity. So therefore ds by dt is treated as v. So now above equation it can be written as dw equal to m into v into dv. Now if the applied force is increases, then velocities changes, velocity is changes from U to V. Then the total work done, then total work done on the body is given by so here total work done, it is treated as W is equal to integral of U to V dW. Here dW means small work done. So here limits U to V. Here U means initial velocity of the body, V means final velocity of the body. So now here dW means mv dv. Is substituted in the above equation. Integral of U to V mv dv. So here m is constant. Here m means mass of the body is constant. So there is no integrations applied on the m. So therefore W equal to m into integral of U to V into dV. So in this situation we know that in the integrations integral of x power n dx is equal to x power n plus 1 by n plus 1 plus c. Here c is the arbitrary constant. So in this situation integral of v into dv means v power n plus 1 by n plus 1. Here v n is now W equal to m into integral of U to V into dv. So in this situation here m into v square by 2. Here limits are u and v. Now W equal to m into, first of all we can substitute upper limit, that is the v square by 2, minus lower limit u square by 2. Then it can be written as W equal to 1 by 2 mv square minus 1 by 2 mu square. Here 1 by 2 mv square means final kinetic energy minus this one is initial kinetic energy. So therefore this is the final kinetic energy minus this is the initial kinetic energy. So therefore work done is equal to final kinetic energy minus initial kinetic energy means change in kinetic energy of the body. So then the theorem is proved. Now we discuss about potential energy. What is potential energy? Potential energy means the energy possessed by a body by virtue of its position or configuration is known as potential energy. The energy possessed by a body by virtue of its position or configuration are called potential energy. So here potential energy are commonly three types, mainly three types. That is, first one is gravitational potential energy. Second one is elastic potential energy. Third one is electrostatic potential energy. Okay. Now, first of all, gravitational potential energy. Gravitational potential energy. First one. So what is gravitational potential energy? It means the energy possessed by a body by virtue of its position from the above of the surface of the earth. From the above of the surface of the earth is known as gravitational potential energy. So it's simply called as the energy possessed by a body by virtue of its position from above the surface of the earth is called as gravitational potential energy. Okay. Now, second type, that is elastic potential energy. It's simply called as P, elastic potential energy. What is elastic potential energy? The energy possessed by a body by virtue of its deformed shape is called as elastic potential energy. The energy possessed by a body by virtue of its deformed shape is called elastic potential energy. So what are the examples of elastic potential energy? It means a spring is compressed or elongated, so then the elastic potential energy is stored in the same spring. Okay. So third one is electrostatic potential energy. Third type is electrostatic potential energy. What is electrostatic potential energy? It means that the energy due to interaction between 2-point electric charges is called as electrostatic potential energy. So it can be written as the energy due to interaction between two electric charges are called electrostatic potential energy. So these are the mainly three types of potential energies are there. Okay, thank you.